I'm going to discuss about oxides of nitrogen. Okay. Nitrogen shows maximum number of oxides, as I have discussed and told you also earlier. Why does it form? Because of the small size of nitrogen and its ability to form double bond or pi bond with oxygen. Okay. So I'll write down here formula and name. Okay. Oxidation state of nitrogen and structure. Preparation is not there, so I did not. I'm not going to discuss. But if you wish that you can get from my copy, as I told you, I'll after a few days I'll give you. So first one is N2O. This is called nitrous oxide. This is also sometimes known as laughing. It's not that if you inhale it, you'll feel like laughing, but you develop a sense of happiness. That's all. Oxidation state of nitrogen is +1. Okay, so its structure is this one, and this is this. Okay, and it undergoes resonance also. You get here this. This is 1, 2, NO. This is called nitric oxide. Oxidation state of nitrogen here is +2. Now nitric oxide has a unique structure. It is an odd electron species. See here you have a free electron. So it is an odd electron species that you studied in class 11. This is paramagnetic. Third is N2O3. This is called nitrogen dioxide. This oxidation state is +3. So it is, its structure is this one. This is the one. Now it can resonate between this oxygen and this oxygen. So in that case, you can draw another structure also. Then you have NO2. This is called nitrogen dioxide. This is +4. This one is also very important structure. It is an odd electron species. Okay, this is brown in color, brown gas, paramagnetic. Why it is paramagnetic? Because of the presence of unpaired electron. Why it is brown in color? Due to the presence of unpaired electron, it is colored. But the same question you can ask me, this is also having an unpaired electron, why it is not colored? Yes, correct. This also should have been colored. But thing is that it depends upon that excitation energy. Excitation energy of this unpaired electron nitrogen, it does not fall in the visible zone. Okay, so in that case, it is colorless. But if you irradiate with ultraviolet light, then it will be colored. So this one you can write resonance structure in this way. Then you can get here N2O4. This is called dinitrogen tetroxide. Okay, this is also +4. This is being formed by the combination of nitrogen dioxide. So this is also +4. The structure is this. See, this is also +4, but it does not have an unpaired electron. So it is a colorless liquid. Colorless liquid and diamagnetic. Six. N2O5. This is called dinitrogen pentoxide. Okay. This is +5. The structure is this one. So this one again can have a resonance structure. Single bond will be here and double bond will be here. Then that you can draw. Okay, this is a white solid. This is a white solid. So I'll write now here colorless gas. This is also colorless.
So done.
Done. Okay. Okay, now some of this information that you should write, you should know. Okay. No. Both nitrous oxide and nitric oxide are neutral oxides. Second, other oxides are acidic. Third, acidity of the oxides increases with increase in their oxidation states. That is, if I write here acidity, N2O5 is more acidic than NO2, then N2O. See, this is plus 5, this is plus 4, this is plus 3. Okay? 4. Both nitric oxide and nitrogen dioxide are odd electron species. That is, nitrogen has one unpaired electron. Both NO and NO2 are paramagnetic in nature due to the presence of one unpaired electron. Then 6. Nitrogen dioxide is brown in color. The color of the gas is due to the presence of unpaired electron on nitrogen atom. Which undergoes electronic transition by absorbing visible. This is very, very important for exam. And this one. Okay. Seven. Nitrogen dioxide on cooling become colorless liquid and diamagnetic in nature. Why it is like this? Let us see. This I explained to you in chemical kinetics. See, this is the one. I'm not writing an electron now. So, okay. See, these two electrons join. And what you get here? Now see, it doesn't have any unpaired electron. Right. Nitrogen dioxide on cooling dimerizes. Dimerize means two unit join. To give N2O4. Where nitrogen atoms do not have any unpaired electron. And so it becomes colorless and diamagnetic. This is also important for exam. Often this question comes. Okay, now one more I'll write. This is not for your board. N2O3, dinitrogen trioxide, is often called nitrous acid anhydride, means loss of. This is free of water. This is because N2O3, when combines with water, form nitrous acid, ANO2. See, I'll write the equation. H2O plus N2O3. So it will give you 2HNO. See, it is, if I come reverse, water gone. Anything which loses water, we call it anhydride. Because of that, it's called this. Okay. Now, next. N2O5 is called nitric acid anhydride. Same thing I'll write now. This is because when N2O5 comes in contact with water, form nitric acid. HNO. So H2O plus N2O5 gives you 2HNO. So all the possible questions which may come from there, I've given.
That's
I told you that if you have any question to ask me, but you never ask any question, then all right. So I'll go to one of the important part of the P block that is called nitric acid. HNO3. Laboratory preparation, but nobody prepares it, but still you should know. See, nitric acid is being prepared by heating sodium nitrate with concentrated H2SO4. It is prepared by heating sodium nitrate. Sodium nitrate also has a name. Okay. We call it chili salt. See, there is a country in South America, we call it Chile. So there, some portion of the chilies, that soil is found to be rich with sodium nitrate. So it is because of that it's called chili saltpeter. So same like that of potassium nitrate. Potassium nitrate is also found many parts of West Bengal or in Bangladesh mixed with the soil. So because of that, potassium nitrate is also known as Bengal saltpeter. Okay. With concentrated H2SO4 below 420 Kelvin. So it is NaNO3 H2SO4 less than 420 Kelvin. You get here sodium hydrogen sulfate and HNO3 vapor. This vapor is condensed. Okay, so you'll get it here. So it is condensed. Cool it. Then you get now here. But we do not go for this one. We buy it from the market. So now we'll go for B, manufacture. So now manufacture of nitric acid by Oswald. Oswald process. In this process, nitric acid is prepared by partial oxidation of ammonia by following steps. কি জিনিস
না তুই বললি যে আমি যাচ্ছি বাইরে কি আসবো
by following steps. Okay. So now first we'll write. তুই ঠান্ডা জল কেন খাচ্ছিস? কেন কি ঝাল দিয়েছে? Partial oxidation of ammonia. A mixture of ammonia and air in the ratio of 1:10 is passed through platinum rhodium gauge catalyst. Now you should understand. Why should I write platinum through? Can you pass any gas through a solid surface? No. Gauge means what? It's just like a wire mesh. Just like wire mesh is there, na? You find your, what should I say, the strainer of your tea leaves. So this is made of gauze. So this type of gauze is being made and packed inside the tube, and so that the ammonia and air can go through. At about 1100 Kelvin. So now to form nitric oxide. Oh, I should not write. Then you will send to form no. Sir, what? Why you are saying form no? It cannot be like this, nah. So I'm very scared of you. To form nitric oxide. And I'll just tell you how to remember this equation. Very easy. Like in roasting, I told 23, 22. Here also you see. Otherwise, sometimes it's difficult for you to remember. Platinum, rhodium, catalyst. 1100. Here you'll get nitric oxide plus water. Now, see, you write here 46. And here you write, sorry, right here 45 and 46, which is balanced. Okay, right. Then I shall go to the top. Today I think your attendance is very poor, but today I don't know. If those who are going to miss it, they will really have problem. I have such a big syllabus to finish. I don't know that I'll be able to finish it before December. I'll see. Otherwise, some portions you will read.
Done, sir.
Okay. And this is very big, this unit. And I cannot go shortcut because otherwise you'll get problem in your entrance exam. Now, second step. Oxidation of nitric oxide to nitrogen dioxide. Okay. Now what you do? See, temperature is very high. So the nitrous oxide gas which comes out, it goes to the pipe and it is being cooled by spray of cold water to the pipe. This the spiral pipe is there, and from the top the water falls. So in this step we do not use any catalyst. Okay. Nitric oxide get oxidized by the oxygen present in air to form nitrogen dioxide. So what is going to happen here? 2NO plus O2, it forms 2N. Okay, here temperature requirement is very less. It comes to almost 50 degrees Celsius, means what? 273 plus 50 will be 323. In your book, somehow it is missing 323. Now, this nitrogen dioxide, whatever is there, now we should treat with water. Okay. So now we'll write here conversion of NO2 to HNO. The nitrogen dioxide gas is passed through the bottom of a chamber packed with broken tiles or pumice stone, and water is sprayed from the top. So what happens now? See, so that tower is called, not tower. That tower is called absorption tower. Okay. So in that case, what you will find? Nitrogen dioxide will react with water to give you 2HNO3 plus NO. Okay. Nitric oxide gas is not soluble in water. So this nitric oxide gas is taken out because it is soluble in water. So right now here, aqueous, and the nitric oxide gas again is which comes out, we dry it, and again we send to this tower. So it is a continuous process. So now it is a very dilute acid. The dilute HNO3 so obtained is fractionally distilled to obtain 68%. 68% HNO3. You call it concentrated HNO. Why you cannot go to 100%? Because in solution chapter I told you azeotrope, remember? So at 68% it forms azeotrope, so further water cannot be separated. Now, if you wish to get 100%, that again I'm telling for entrance exam. So we stop here only. To obtain 100% HNO3, 68% HNO3 is kept over either concentrated H2SO4 or P4O10, phosphorus pentoxide. These are very strong dehydrating agents. In a vacuum desiccate. What happens now? When this nitric acid undergoes evaporation, water comes out because boiling point of water is less than that of nitric acid, and water is being absorbed by these two of them, and nitric acid comes back. So by that way, you can obtain 100% nitric acid. But we never use 100% nitric acid because it is explosive in nature. Caution. 100% HNO3 is generally not used as it is explosive in nature. All right. Now properties. It is a colorless fuming liquid. Means what? Considering nitric acid is colorless, but you open the bottle, you find the vapors are coming out. So it's called fuming liquid. But may develop yellow color when exposed to light and air. It is because HNO3 decomposes to nitrogen dioxide in presence of light. See what is going to happen now. See here. 4HNO3. It gives you 2H2O, 4NO2. This is the yellow color, glass oxygen. However, when it becomes yellow, you need not throw it. However, the acid can be obtained by bubbling air to it. So I'll write the equation again opposite. Yes. Yes, tell me. Auntie is doing puja. Tell me.
Give me dry chili.
Dry chili.
2-3 pieces. My pork is becoming very pale.
क्या
Chili.
Oh, red.
Red. Not that's too much.
Hey, what too much? Tomorrow is also much.
Thank you.
Oh, this one.
Yes. I have chili powder
Hmm.
made from home. But when I put in pork, the color doesn't look nice.
Oh.
I want to make fried. Thank you.
So what we'll do? Again, we write this equation. Right hand to left hand will write. So this is important. That is the one. Finished?
Yes, sir.
Yes, sir.
Hey,
Yes, sir.
why every time I have to tell you? Like this is the process becomes so slow. Sometimes I lose interest also. And only I have found only 2 of you are saying. Others say simply keep quiet. I'm getting now disinterested with you people. Because you are not interested for study. By teaching you, I don't understand whether you understand or not. As if you are being forced to teach. Chemical properties. Acidic character. Nitric acid is a strong monobasic acid. What does it mean? Monobasic acid? That is, it gives only one H plus ion. See here. HNO3 aqueous, it will give you H plus aqueous and NO3 minus aqueous. It turns blue litmus red. It reacts with bases to form corresponding nitrates. What are the bases? This equation, why should I write? Sodium hydroxide, HNO3 will give you sodium nitrate, H2O. Suppose you have taken, this is hydroxide, suppose you have taken here oxide. So it will react with calcium oxide to give you calcium nitrite, H2O. Suppose you have taken carbonates, potassium carbonate, 2HNO3, it will give you 2 potassium nitrate, H2O. If you have taken bicarbonate, it will react with nitric acid to give you sodium nitrate. Oh, sorry, carbon dioxide. Carbon dioxide. If it comes in contact with ammonia, it will give you ammonium nitrate.
Done, sir.
Done, sir.
For your information, this is note. This is again for your extra information. All metal nitrates are soluble in water. Is very interesting. Other acids, salts are, all of them are not soluble. See, nitric acid is not that used as normal acids. Nitric acid is an oxidizing. So it is being utilized for oxidation. Oxidation reactions. Nitric acid is mostly used as an oxidizing agent. Under different dilution, under different strength, it gives various products. Okay, then first I'll write the basic equation. Then after that, after a few days, you'll be expert. Only you'll ask the person, what is the concentration? What you write the product. So you write here. Hot and cold concentrated HNO3. So I'll write now here. HNO3 under this condition, it will give you water, nitrogen dioxide, and oxygen. So let us balance. Because it's an oxidizing agent, all of them will give oxygen at different concentration or strength. See, you have two hydrogen, here one. Now, here you have two nitrogen, here you have one. So hydrogen and nitrogen balance. How many oxygen is there? 2 into 3, 6. So 1 plus 4, see, plus 4 plus 1, 5, and 1, which is 6. So I'll put it under square bracket because it is atomic oxygen or nascent oxygen. So this is 1. Okay. We'll write now here. Moderate. This we have diluted it. Okay. So it will give me HNO3 will give me, this is called nitrogen dioxide, you know, still I will write nitrogen dioxide. And from there, you will get a brown vapor. Whenever you use concentrated, hot or cold, is going to give you a brown. The solution will be brown. Now, this will give you H2O, NO plus oxygen. What you will get now here? You will get here nitric oxide is colorless. So again, I'll balance 2. I'll write that 2 nitrogen. Now let us see the oxygen. 1 plus 2, 3. So here 6. So what should I write now here? I'll write now the oxygen. Okay. Then I'll write here C. Okay, I'll not write moderate because you may get confused. I'll write here di. And here I'll write cold. Very dilute. This is dilute and this is very dilute. This is hot. HNO3 will give me water. N2O, see the interesting thing. Because of that, nitric acid is important. This is, you get here nitrous oxide, that is the laughing gas. So I told you, is laughing gas means if you inhale, you will not start laughing, but you have a sense of feel good. Nitrous oxide is used in major operation. See, when major operation is there, patient is being made senseless by putting some anesthetic agent. But anesthetic agent, if it is in more, then patient may die. He will not come to sense. So only during the when the operation started, on initial stage only the anesthetic agent is supplied, and later on it is being reduced and they pass nitrous oxide. Why? In that case, patient do not feel so much of pain of the operation. Okay, now see, again I'll balance two hydrogen, nitrogen is already 2. So hydrogen, nitrogen is balanced. 6 oxygen, 1 plus 1 is 2. So value mass that 4. Using this one, now we'll do rest of the equations.
Done, sir.
Done, sir.
Now we'll do some examples of oxidation. So now we'll write oxidation of non-metals. Of non-metals. See, non-metals are oxidized only by hot and concentrated nitric acid. Non-metals get oxidized by hot and concentrated HNO3. Now, in that case, what equation you are going to use? This is our basic equation. I have already told you. You'll find in your school, they will not explain all these things. It's not that I'm condemning your teacher. Okay. So this is the equation, you will use it for all non-metals. Okay. Now I'll write here 1. Carbon to carbon dioxide. All right. So I'll write this equation. I'll go for now partial equation. I will not go for straight cut equation you're given in a book. In that case, if you don't understand, you have to by heart. If you follow my technique, every equation you can write. See, I know the equation is what? This is my equation. H2O, I know the secret now. See here, carbon. What is the product? The product is carbon dioxide. So how many oxygen you require? You require 2 oxygen. Now, to get what? Carbon dioxide. Now, who is going to supply this oxygen? So first equation is giving how many oxygen? 2, sorry 1. So I have to multiply it by 2. See, it has become, life has become so simple. So you remove this. So what you will write now here? 2 into 2, 4. 4 HNO3. It will give you 2 H2O. 2 into 2, 4. 4 NO2 plus carbon dioxide. Finish.
Sir, can you repeat again?
See, we are being told that carbon is being oxidized to carbon dioxide. What is the oxidizing agent? Hot and concentrated HNO. We know that this is the basic equation. So I have written this one. This is giving us atomic oxygen. Atomic oxygen is a very strong oxidizing. This atomic oxygen is only going to convert carbon to carbon dioxide. So I have written the equation C plus O CO2. How many are there? 2. So I have to write 2 here. Who is going to supply oxygen? Obviously, you are not going to carry in your pocket. This has to be supplied by the nitric acid. So it is giving 2, giving 1. So I have to multiply by 2. See now, 2 oxygen, 2 oxygen. After that, I have added it. Finished. Understood now?
Yes, sir. Thank you, sir.
Now, second is sulfur to H2SO4. Don't get nervous. This is my equation. Okay. So I'll write now here sulfur. I'll explain it by the elementary equation. Sorry, simple equation. Then I'll do it according to your book. This is sulfur. Sulfur carbon, highest valency of carbon is 4. Because of the C2 into 2 is 4. Highest valency of sulfur is 6. So in that case, as it is a very strong oxidizing agent, it is going to convert into SO3. How many oxygen I require? Here? How many? 3 or not? Huh? So I'll write here 3. So this 3 oxygen is provided by the first equation. Then what should I write here? 3. So we get SO3, but in the equation you go H2SO4. Please remember, SO3 immediately reacts with water to give you H2SO4. See here. 3 plus 1, 4 oxygen, 1 sulfur, 2 hydrogen. But you can ask me that why I did not do it for carbon dioxide. See dear, carbon dioxide also reacts with water to give you H2CO3 or carbonic acid. But carbonic acid is not stable. It breaks down to give you carbon dioxide. See, this carbon dioxide is being put in your aerated water, all your so-called soft drinks. Moment you open the bottle, what happens? Is it not the carbon dioxide comes out? That is carbonic acid is not stable. But sulfuric acid is highly stable. So see, concentrated nitric acid is what? 68%. So 100 minus 68 is what? 32%. What is 32%? Water only. Okay. So in that case, it will react. So let me add it. So don't get scared by the 3 steps or 2 steps equations. See, normally equations you have to balance, you have to spend 5 minutes. It takes less than 1 minute. So I'll cross this, see this and this. So what will write here? S. How many nitric acid? 3 into 2. So it is 6. 6, 8. Now how many molecules of water? See here, 3 into 2, 3 molecules in the right hand side, 1 molecule in the left hand side. So you have to subtract this one from this. So I'll write now here 2H2. So you will get now here H2SO4 plus I made a mistake. Sorry, dear. I made a very serious mistake. You know what is the mistake I have done? I'll tell you. 3 molecules of water is the right hand side. 1 is on the left hand side. The water will go to the right hand side. So it will be H2SO4 plus 2H2O plus 6 NO. Right.
Done, sir.
Okay. Now in your book, this equation is not being given like this. I have written the atomic equation is 100% correct. Okay. In your book, sulfur, see, sulfur as an element exists as S8. So how many you will get? Yeah, 8 SO3. So you don't get scared. Sulfur, whether it is one atom or S8 is the molecular formula. If 8 sulfur atoms are there, all 8 sulfur atoms will be converted into sulfur trioxide. So 8 into this. So now for each sulfur you require 3 oxygen. So 8 sulfur you how many oxygen you require? Huh? Each sulfur requires 3 oxygen. 8 sulfur will require how many oxygen? Tell.
24.
So right now we are 24. What problem we have? Nothing. Who is going to provide 24 oxygen? This one. So please write here 24. Okay. So it will be what? 8 SO3. I'll write here 8. Okay. And you will get here 8 H2SO4. So same equation you will write S8. How many molecules of nitric acid? 2 into 24 is how much? 48. It will give you what? 8. See, 24 molecules of water minus 8 comes to how much? 16. And 24 into 2 is how much? 40. So any equation which you feel convenient, you can write. Whether you can write with 1 sulfur atom or you can write with 8 sulfur atom. Both are correct. Why? Why I'm saying why it is correct? Because we know from laws of chemical combination and also from Dalton's theory that it is the atom which reacts. So sulfur molecule will break down into 8 sulfur atoms. And each these 8 atoms are going to react. So if I write for 1, is applicable for 8.
Done, sir.
Okay. Now I'll write here phosphorus. That I will learn it later on after finishing this nitrogen. Phosphorus exists in different allotropic forms. The phosphorus which is highly reactive is white phosphorus. White phosphorus consists of 4 phosphorus atoms. So it will give you H3PO4. All right. So now, again I'll write the same. Okay, this. Now I'll write here P4. See, it's very interesting here. Phosphorus, just like sulfur is being converted to sulfur trioxide, and whatever I have written is not imaginary, it is the actual thing. So phosphorus will be oxidized by concentrated nitric acid into phosphorus pentoxide. Though we say pentoxide, but it contains 10 because 2 pentoxide molecules join together. That I'm going to show you for your entrance exam is not in your book. See, P4O10. Then P4O10 reacts with water to give you H3PO4. How to balance? Very easy. Write 4 here. So 4 into 3 is what? 12. We require 12 hydrogen. Each molecules of water contain 2 hydrogen. I'll write here 6. Blood depth. Now I have to balance oxygen because I did not write. How many oxygens are here? How many?
10.
So I'll write
10.
here.
Done, sir.
Who is going to provide 10 oxygen? Which equation? By the first equation. Balance. Now see, you remove this, remove this. Okay. And after that, you add. Always do like this. You'll never make mistake. Shortcuts are not good.
Done, sir.
Good. Now we'll go for iodine. H3PO4 is called phosphoric. We'll do for iodine. It's very easy. See, at home today, you just practice it 2 times. You will not forget for your whole year. I2 to HIO. Okay, this is called iodide. So this formula you have not seen earlier. So I'll now remove this. I'll write now here. I2 plus oxygen. First intermediate step is I2O5, iodine pentoxide. Iodine pentoxide reacts with a molecule of water to give you 2HiO. So you have how many oxygen? 5. So I write here 5. So I'll multiply by 5. See, this and this will get cancelled, this and this will get cancelled. Add it. Remember, you have water distilled and you have water distilled.
Done, sir.
Okay. So with this we finish oxidation of non-metals. Okay, many are there, but as it is not in your syllabus, so I'm not going to write. Now oxidation of metals. Okay. So I can classify this into 2 categories. Oxidation of more electropositive metals. What is the meaning of this more electropositive metals? We'll write here negative standard reduction potential. Okay, science book should be written systematically though. Huh? It should be written like storybooks, na? Potentials. Example. Okay. So now here is C. Suppose it is a boxing competition is going on. 2 persons. I am very bad in. Huh? So this. So referee told go ahead. In that case, what happens? the person who is more agile, he is going to land up the washing first, followed by the other one. Other one will duck. So when you have taken nitric acid is an oxidizing agent. If nitric acid is oxidizing agent, then others is reducing agent. All right, because oxidation and reduction takes place simultaneously. So if the reducing agent is stronger, it is going to attack first the oxidizing agent. And if the oxidizing agent is stronger, then it is going to attack the reducing agent first. It's just like that we are having a quarrel or discussion. Suppose you are talking with your friends. Both of you don't start together. One starts, others follow, then others takes. So it's just like this. So we know that zinc is having a reduction potential of minus 0.76. So it is a stronger. What is going to happen? Zinc is going to react with nitric acid. We know metals more electropositive metals or metals with negative reduction potential, when they react with acid, they displace hydrogen. Okay, I'm going to take little more, huh? So don't get impatient, because other days I have to take class 11, so because of that I feel tired. See here, I will not write H2. You know why? Because nitric acid hardly liberates hydrogen. That is important for your entrance exam. So 2, so I'll write here. See, this hydrogen is going to reduce the nitric acid. So I'll write here. I'll write here. 1 with concentrated HNO. Sorry. Okay, now see here. So I'll write this equation for nitric acid that we know it. So it will, what will write now here? H2O, then 2NO2 plus O. See, atomic hydrogen is there, atomic hydrogen is there, atomic oxygen is there. What is going to happen? They're not going to smile at each other. They'll simply react. Give you what? Water. All right. So I'll add now. This cancel. This and this get cancelled. So I'll write now here. Zinc 2 plus 2, 4. 4 HNO3 will give you zinc nitrate. 1 plus 1, 2. 2H2O and 2. Finish.
Done, sir.
Okay. Now I'll do it. Dilute hold and dilute. See, it's not very dilute. HNO. So I'll write the same thing. See here, zinc plus 2HNO3 will give us what? No, not hot. It's hot and it will give you zinc nitrate. Then 2 hydrogen. See, hot and dilute acid, what does it give? We already know. It gives us H2O, N2O plus oxygen. So I'll balance it. 2 and this is 4. We have already done at the beginning. So now see, Here it produces one oxygen. One oxygen, no. It is reacted with two hydrogen. How many oxygens are there? 4. So anyway, I'll write like 2H plus 4. I'll take that from the equation. 2H plus 1 OH. Okay, I'll write now H2. All right. But how many oxygens are there? 4. I shall multiply it by. How many hydrogen I require? 4 into 2. How many? 8. First equation is giving me how many? 2. I have no problem. I multiply by 8, 4. See, now 8, 8. So this and this will get cancelled. This and this will get cancelled. Add it.
Done, sir.
Done, sir.
This is often asked in the exam. Why? Because of the nitrous oxide. Because in your book, this is the only equation which gives you nitrous oxide. See, exceptions are always dangerous. And my request is that after your tuition is over, please sit down for some more time and repeat this equation that I have done it for you. You will not forget. Okay, now we'll go for less electropositive. Oxidation with less electropositive means what? Positive reaction potential. So I'm giving a theory, mind it, instead of that one, if they replace the metal also, you know. Example, copper. See now, this is not a strong reducing agent. And we know any metals with positive reduction potential can never give hydrogen from any acid. Oxidizing acid, non-oxidizing acid. So who is stronger? HNO3. So write down here. With concentrated. So I'll write first equation. View H2O, 2NO2 plus oxygen. See, metals, whenever they come in contact with oxygen, they form oxides. What you will get now? Copper oxide. Any metal oxide is a base. And acid and base, if they stay together, they'll always react. So copper oxide plus 2HNO3 will give you copper nitrate plus H2. This cancel. So I'll write here now. Copper 2 plus 2, 4. 4HNO3 will give you copper nitrate. 1 plus 1, 2. 2H2O plus 2 nitrogen dioxide. Now, try to understand, don't write. See, whenever a compound breaks down to give you many other compounds, we call it decomposition. All right. So I'll write here decomposition. Okay. Addition of oxygen is called what? Oxidation. Reaction of acid and base, what you call it? Neutralization. How to remember? Very easy. Done. So first step is D for decomposition. Second is oxidation, and third is neutralization. So this you can do it by process of dot. Right.
Done, sir.
So now we'll do the next one with dilute HNO. See, dilute, not hot. Dilute HNO3 gives you what? It gives you H2O, NO plus oxygen. So I'll write here 2, NO, it is 3. See here. Copper plus oxygen gives you copper oxide. This is done. DO. And copper oxide is going to react with nitric acid to give you copper nitrate and water. Now see, how many oxygen you have here? 3. So you have to multiply it by 3. Moment to multiply by 3, how many copper oxide? Here you have 1. Here you have 3. So we'll multiply this equation by 3. Let depth. Edit. So try to make things simpler for you. Then you will not have any headache. Chemical equations are not headache. Don't get scared.
Done, sir.
You can solve everything. Okay, then bye for today. So next day I'll take little bit, then I shall move to phosphorus.
Thank you,
Thank you,
sir.
sir. Bye, sir. Good night.
Good.
Thank you.